Hello and welcome to ESA 2019. I'm Buck Endeman. I'm an energy lawyer with K&L Gates, and here with me today is KJ Plank, a product manager at Doosan Grid Tech, and Sean Kilgrow, who's the director of project engineering. Thanks so much, guys, for joining us this morning. I've been over to your booth. There's been a lot of buzz, a lot of excitement, a lot of people, so thanks for taking a couple of minutes. Sean, maybe you could start us off. Describe Doosan. What do you guys do? What are your product lines?
Sure. So Doosan's a design-build firm from Korea, Doosan Heavy Industries, focused mostly on power infrastructure and water infrastructure globally. They're bringing that capability to North America and focused in on the battery storage market. It's the type of work we're looking at here from an EPC perspective is design build in nature. So we have all that in-house right now, and the projects are coming through in a way that it's mostly for utilities right now. Because it's a first of a kind, many of these battery storage systems. Some of them, from a utility perspective, it's in a way it's a science experiment. So we got to be very flexible with the customer's needs and how they approach the project. So we built a team around that, and we're deploying for several utilities here in the country.
Excellent. So it sounds like the hard tech side. Mm-hmm. So what differentiates the grid tech side, KJ, from what your competitors are doing?
Yeah, good question. I think, Sean was sort of alluding to, we have, deep expertise in energy storage, from sort of the design to the delivery and the field support. But I think what differentiates Doosan Grid Tech from our competitors is that, we started not as an energy storage company, but as a sort of software company first. And so we started with the understanding, with the foresight, that energy storage on its own is not necessarily an intelligent asset. And in fact, it's only as capable as the software that's controlling it. And so we're based in Seattle. It's a tech hub. We've got a lot of talent up there, and we've developed a pretty incredible control software platform for energy storage and for other DERs. And this platform, it's time tested, it's field proven. We have hundreds of thousands of uninterrupted hours in the field, and uniquely we've committed to having our customers, or I should say helping our customers, de-risk their investment by fully committing ourselves to using open communication standards in our software. That's things like OpenADR, SunSpec, and I think most relevant and important to this conversation would be MESA.
So what's so important about MESA? And are you guys early adopters, or is this something that a lot of people are embracing?
Yeah, no, that's a good question. So, MESA is a standard that defines the way that energy storage systems communicate. It defines the way that energy storage systems communicate, let's say at the device level, between an energy management system and maybe a battery management system. And it also defines that interface between the asset itself and whatever's controlling. Maybe it's a utility SCADA or operations center for an IPP. And that standardization is important for several reasons. Companies are tired of being sort of siloed and locked into proprietary system designs and communication protocols. And so what MESA does through that standardization is it unlocks competition, it lowers upfront costs by reducing the time that it takes to integrate all the components together. And as I mentioned, it de-risks investment, because what it does is it gives firms who operate these assets, it gives them the elbow room, the choice they need to adjust their operating strategy down the road. So if you're 5 years past COD on an energy storage system, your inverter fails, maybe there's some new technology out. If you've procured a system that's fully MESA compliant, the device level and the software, that means that you can put in a new inverter from a different manufacturer. So it's as close to plug and play as energy storage gets today, and we're a proud supporter of the MESA standard because of the benefits that it offers to our customers.
Now, is that MESA standard? It sounds like the goal is to make sure everything works together and everything is efficient, resilient, and seamless. Is embracing an open source standard something that a regulator should be concerned about or thinking about?
Absolutely. We think it's important for all stakeholders in this space to be thinking about. A regulator would be a good example. I think this is something that's really sort of picking up momentum with utilities now as well. Duke Southern California Edison, LEWP, those are some big name utilities that are committed to using the MESA standard. 8-minute energy would be an example on the IPP side. So it's something that's really starting to gain momentum, and we're proud to be a part of this.
Excellent. Sean, anything else to add on the MESA standard? You're responsible for delivering these things. Right. So has it been a challenge? Have people embraced it? Is there an education component?
There is, and if you think back to the solar industry, go back 10, even more years ago, so many new companies coming into the space. Won't use a bad example, but some companies have failed. And if you have a company that has failed on your project and you need to replace, let's say, an inverter, how big of a deal is that from a design perspective? In the past, it's not been plug and play. And if you think about those companies that are doing that, are actually responsible for the power coming off that system, it can be a very painful thing. And that's why MESA is so important. You can just take out a component and put in a component. And it's all about de-risking the project, and not only from the component perspective, but as you go upstream a little bit and you look at going back to the construction. Now, right now as we sit, many of the battery storage systems are not that complicated from a construction perspective. The complicated part is really is inside the balancer system, the actual from the battery storage system to the inverter, and how those communicate. That's where the predominant risk is, in my view, in the long-term success of that system. So that's where MESA really plays into this, and we've fully embraced it, and we hope that more and more people come on board and adopt that standard.
Great. So we've heard about the approach. Let's talk about the execution. Any projects stand out, Sean, as lessons learned or good exemplars for the industry?
Oh, absolutely. And as I mentioned, most of our projects to date have been with utilities. LADWP is a good example, Austin Energy, Snohomish PUD. But one we're executing right now currently, 2 projects for Duke. One is a solar plus storage, and the other is we have a lithium ion and a flow battery on the other project, AC coupled and DC coupled. So there's many lessons learned here. And of the folks out there that are thinking about, let's say, retrofitting an existing system, very hard to do on a DC side. AC side, it's because you can interconnect with the grid and use that power to charge the system. It becomes a much more designable system, if you will, and applicable to the long-term financial success of that retrofit.
Excellent. All right, so last question. KJ, we're going to see each other next year, I'm sure. What are we going to be talking about next year at ESA 2019 or 2020?
Good question. I think we're going to see a lot more sort of conversation around solar plus storage.
Yep.
It's something that's just starting to sort of build momentum now. We're seeing increasing deployments. Frankly, there aren't a lot of good solutions out there today for solar plus storage. We're happy to say that we've developed an AC coupled and DC coupled control solution for solar plus storage, and I hope that next year that's one of the things we'll be talking about.
All right, Sean, same question.
I would agree. It's you're going to see more standalone, and with the use cases becoming, well, it depends on where you're at. In California, it's mandated in many cases, the 1.3 gigawatt. The IPPs are getting more into the space, and you're seeing, instead of just standalone container, I think you're going to see a shift towards building enclosed solutions, and that. There's lots of advantages from a HVAC perspective. Once you get to a certain size, that thermal load, you got to control it. And if you're in the desert, a building makes more sense. More like a data center, if you will. So you're going to be talking about buildings, solar plus storage, and is it DC or AC coupled? As ITC starts to fade away, does that DC coupled component become less and less attractive to finance folks? So I think you're going to be talking about that.
Excellent. Well, appreciate your perspectives, both KJ and Sean. Thanks so much for joining us, and see you next year.